Okay, now that we covered NumPy, let's jump on to Pandas. And don't worry if you think that you haven't covered everything yet, because as long as you know you could do something with NumPy, you could always Google it and find the codes. That's what I do all the time. So let's now move to Pandas. So Pandas is a library for data manipulation and analysis. You could just think of it as similar to a spreadsheet. And as I introduced earlier, they are composed of matrices, so they need NumPy to run it. And on the bottom, you can see a Pandas data frame, and that's how data is represented in Python Pandas. And the data set we're going to be using today is Iris, and I think any of you who have ever had experience with Python or R would have like at least be familiar with this data set because it's so famous. So Iris is a flower. There are three types: Iris setosa, Iris versicolor, and Iris virginica. People collected these flowers and measured their sepal length, sepal width, petal length, and petal width, and made it as a data set. And with these data set, you could distinguish whether an iris belongs to setosa, versicolor, or virginica. And on the right bottom, you can see the graph, which has divided iris into class 0 and class 1 and class 2 based on the petal length and sepal length. So yeah, that's what you're going to be doing with Pandas and matplotlib, but we're only going to be using Pandas for today. And Iris is actually stored in UCI repository, and it's just a storage of diverse data, and all data are kind of cleansed and it's neat, so it's perfect for practicing basic coding, regardless of what model you're using. It could be Pandas, it could be Matplotlib, it could be SciPy, sklearn. Doesn't matter. It's like real basic stuff, and not only Iris, but heart disease, wine quality. Yeah, all those data sets are very frequently used, so it's good to get used to those. And this is kind of like going to be your assignment for next week, but I'll get to it at the end of coding. So we'll move on to the Jupyter Notebook again and try using Pandas by ourselves. Now, like we did in NumPy, let's start running the codes in Jupyter with Pandas as well. So first we have to import. We're going to use NumPy as well because Pandas is based on it. So we import both. And then, so Pandas is composed of two data structures. One is series and another is data frame. Series is closer to a vector, while data frame is closer to a matrix. So their dimensions are different, but we just call it data structures for now. And we're not going to look too deep into it, but series is one-dimensional and data frames are two-dimensional. That's just the difference. So it kind of looks like a list. So let's try making an array first. Array equals. We're going to use the NumPy function that we dealt with earlier. Let's use random. Random. Remember this, right? First variable start, second variable end, and then size equals, let's say 5. So it's going to return a, random. Okay, it's going to return a list-looking array, one-dimensional array. With this, we're going to make a series, pd.series. Oh, this has to be capital. If it's lowercase, it's going to print out an error. C, no attribute series. It's really important to write it in uppercase because it's not going to read S1. Then it's going to return a series with the list within it. And you can see how it is indexed on the left, just how it is on Excel or a spreadsheet. This is why it is used for data and when you're touching with data. So next, we're going to try use indexes. Try to change those indexes. Let's say indices. Index equals. Let's go with alphabets. A, B, C, D, and E. Of course, the number of indices have to match the number of variables within the series, so I'm gonna put in 5, then pd dot s2. Let's say that as series pd dot series array with the index as index. Oh, I think it's better to change the name of this because it gets confusing. It does work perfectly fine like this, but some people might have a hard time distinguishing. Well, after you get used to it, that's not a problem, but for now, devices, yeah. It doesn't really matter, you know. S2. Yeah, like that. See how the indices have changed to A, B, C, D from 0, 1, 2, 3, 4. Right? We're going to move on to, wait, I just did changing the index. So we'll skip this. And we're going to create a series from a dictionary. Let's make a dictionary first. Dictionary equals, what should we go with? A equals 1000. B equals 100, and C equals 99. Then we print dictionary. What's wrong with this? Oh, it's not this one. The dictionary is this. It's not an equal sign. Yep, and here we have a dictionary. To create a series using dictionary, you just do pd.series. With the dictionary, it's going to work perfectly fine, and it creates a dictionary with the keys as the indices and values as its corresponding values. And then we could slice these as well. So let's bring back S2 for now. If we do this, it's going to print the whole stuff, just like the list. If we do this, it's going to get rid of the first one. We do 3, 2, 5. It's going to print out the third and fourth value. It goes the same as list and for NumPy, and that's just how it goes. And then we could append series. So remember how S1 looked like this, and S2 looked like this. See, we're gonna append S2 to S1, S1 dot append S2. We're going to print out the appended version. So see how the indices of S1 are here, values and indices are here, and then ABCD is appended right below the values. All right, and then there's also a drop function. So if we have S1, if we drop something from S1, it's going to drop 1. If we have S2, if we do S2 dot drop, it's going to drop a value from S2 as well. All right, and then we'll move on to data frames. And actually, before data frame, I forgot about these operations. So let's say there are two lists. List 1 equals just whatever you want. 10, 100, this large. 23, 5, 9, 10. Let's duplicate it. List 2 equals 5, 7, 11, 10, 8, 7, 8, 99, 123. Yeah, we have 2 lists now. And we're going to create a new list, new series using pandas pd.series list 1 plus list 2, and then it's going to pop out a bunch of lists with these, and then we can make a second series using a single list. Alright, so we have 2 series now. Alright then, what can we do with this? We could add these. Okay, let's see how this works. We added 10 to 5, 5, 15, 23 to 7, and we're 30. If we look below, 7, 8, 9, 10, and 11 values are not assigned. It says not available, NaN. Why is that? 8, 9, 10, 11, 7, 8, 9, 11. We have values here, but we don't have values here, so we couldn't add those up, which makes us have a NaN. So it's just a not available number. Yeah, and it's the same as an empty space, a none, a null in C, and all those stuff. And then if you could do addition, you could do multiplication as well. S1 times S2. That's possible. Division, possible as well. What else can we do? Oh, let's do some statistics. S1 dot mean is gonna calculate the mean of S1. Let's use print function again here. Mean. Okay, we have this one. The dn max and min. Yep. So we could derive the mean, median, max, minimum, all those statistical values from here. It's not like I know every single code to derive statistics. Every time I need something, I look up for it. If I can find it on Google, I use it. That's how it goes with Pandas, NumPy, and all other codes. So it's great to just know what you could do with these codes. It's not essential. It's good to know, but it's not essential that you memorize every single code. So it's just good to see how it works and how it goes. And then we're going to deal with data frames. Okay, so till now we tried some things, how to select things using series, how to select data within Pandas. So now let's use an actual data. So I guess Pandas is already imported, but that's PD. And we should name our data. I told you that we're going to be using iris dataset today. So iris equals pd pandas dot read csv iris. Normally this should work if iris csv is in the same folder as your Jupyter notebook, but it won't work because it's not in the same folder. In this case, you have to find the location of your iris dataset. Mine's is over here. So I'm gonna move this. Okay, go here, and then it's gonna give me the location of that file, and then I'm going to put it here. And for some reason, there's a Unicode error in Windows, so you have to make 2 backslashes. For Mac, it's gonna work just fine even if there are single backslashes or a W-shaped one. It's gonna work either way. So this is gonna find my iris dataset, and if I do iris, it's gonna print a data frame, a 2-dimensional, which is 2-dimensional. If I look at the CSV file, it's the same over here. Exactly the same, right? With the indices, we start from 1 here, but we start from 0 here. Simple length, simple width, petal length, petal width, and species. So this is how you bring a CSV file from your local computer to Python, Pandas. It works just fine for regular Excels and TSVs, but iris data is stored in a CSV format, so I chose to use pd.readcsv over here. And this will depend on the type of your data you're going to be using. If it's in a form of TSV, you're going to have to do read TSV. If it's in Excel, you're going to do read Excel. That will depend on your choice. So if you print iris, it's going to be like this. So what can you do with this data frame? First, let's look at a few data sets. First, iris.head will turn out 5 dataset from its beginning. If we say 10, it's going to print 10 dataset. And we could try tail as well. So the default is 5. Tail 10 is going to print out 10 from the back. Just tail 5 from the back. And let's see how it looks like. Iris.shape is 127 times 5 matrix format. 127 data multiplied by 5. It'll be all the cells within this data set. And what else can we do? Iris dot species is going to return the column only with the species from over here. It's going to erase all these, and it's only going to return those in the species section. It works just equally. It's exactly the same when you do this. The difference between the two is not much. They act the same. But this one is looking for an index, which is named species. Meanwhile, this one is looking for a row with the name species. So they act the same, but are using a different format. So it's just good to know the two, because people kind of alternate between the two. Yeah. Both works just equally fine. If you try trimming this data 10 to 50, I guess you'll know what will happen. Yep, it's only going to return those from 10 to 50. Yeah, not 50, 49 actually, because it doesn't include 50. And what else could we do? Oh, we could print out iris multiple rows using lists. It could be simple length, and simple width. Wait. So, and put it here. It always has to be a string. And why a type error? Android, this doesn't work. Oh, it's not like this. It has to be like this. Yeah, that was my mistake. It has to be in the form of list like this, within a square bracket, in order to print out multiple rows. And then grabbing the location of the data, iris.iloc index, integer location would be if we say 10, it's going to print out the 10th row, which is 5.4, 3.7, 1.5, and 0.2. That was my group with the species Setosa. And what else could he do? We could grab a specific row and column, which is a coordinate. If we say iris.iloc, you should probably like guess it from now. 10, 3. It's going to return 0.2, which is here. It's going to be 10th and 3rd. Actually 4th, because it's 3. That's what it returned. And another function we could do, is iterating through for index and row and iris dot iter rows. If we use this function, it's for loop. If we print idx and row, it's going to return the index and its row. It looks kind of really awkward, but yeah, it's going to return the 2. If we set it as species only, it's only going to return the indices and species, right? That looks much better then. One more thing we could do is sorting the values. Iris dot sort values, and according to sepal length. And this is going to sort the values according in the order of its sepal length. So this is in the ascending order. If we don't want it, if we want descending, we could do ascending equals false. And then it's going to go to a descending order, right? And we could merge the add the numbers in respective columns as well. So if we want to create a new column, we should say df. We define the new stuff, sep total. If that's what I want to say, it should be a df sepal length, and add that to df sepal width plus df sepal width with a should be here, and then it's gonna it's not df. What am I doing? It's iris. Now I was confused because I normally use df because it stands for data frame. Yeah, and this is how it's gonna work. If we print iris, then there is this new line with the sum of the sepal length and sepal width, which returns 8.6, 7.9, 7.9, and so on. So this is how you like kind of mingle with data, and these are only the basics. So you could find more interesting ways to play with pandas by cheat sheet. There's a pandas cheat sheet actually. So if we go here, there are a whole bunch of stuff you could do with it. We don't have time to look through every single one of them. I hope you could, if you're interested, look through all these and try to see what you could do with all those data. Well, there's another cheat sheet, so there are 2 actually. This one could help a lot. I believe I could find it somewhere on the web, but couldn't find it right now. And until next week, try practicing using these codes by Alright, so I was actually going to tell you guys to use a UCI repository, but I found a Kaggle dataset is much more interesting compared to that because, first of all, Kaggle is in CSV file, but UCI is in names and data file, so you have to merge them together. I thought it would be kind of bothersome to merge it by yourself, and I realized that Kaggle provides all these CSV already. So if you go inside, there are these CSV. Download it, it's going to pop up like this. And if you open it up, there's going to be a brand new CSV file you could use. All right, so try to use these as practice. Yeah, that's all. And next week, I'm guessing that you're gonna present the data you've analyzed. So just tell us what data it was and how it looked like. Yeah, and all those stuff. And I'll probably tell you guys more in detail during our Zoom meeting. All right, thank you. Bye.